How can I solve multi-step equations? All right. So the first thing I'm going to do is solve this equation. There's several steps to it, so that's why it's multi-step. What we're going to do first is we're going to distribute some factors here. This first one is 1/3. So when I do 1/3 times 3, it's 3/3 x plus 1/3 times 9 is going to be 9/3. These will simplify down to 1 and 3 respectively, and we'll get to that in a minute. This is nothing to distribute, so the 5 stays the same. Now this minus is part of the 3, it makes it negative. So we're distributing a negative, and we have to be very careful with this. -3 times a positive x is -3x. -3 times a -2 is positive 6. Again, double check it. -3 times x is -3x. -3 times -2 is positive 6. Now I can combine like terms and sort of reduce these fractions. So 3/3 is just going to be 1x plus 9/3 equals 3 equals 5, and then we have the plus 6, so that'll be 11. So it'll be -3x plus 11. Now I can work on moving my variables around. Again, I like to eliminate the lower coefficient, so I add 3x to eliminate this, and I add 3x over here, and x plus 3x is 4x plus 3 equals 11. Now I'm going to subtract 3 from both sides. This will be eliminated. 11 minus 3 is 8. That's going to equal 4x. Divide by 4. Divide by 4. And x will equal 2. 8 divided by 4. Now, you're going to see problems like this, and there are these scenarios in which you have all these relationships between different numbers. In this case, we're talking about people's ages. Allie is twice as old as Kate. Josh is 5 years older than Allie. The sum of Kate and Allie's ages is the same as Josh's age. So as soon as we see this, we know we're going to set up an algebraic equation where we do Kate plus Allie equals Josh. It says how old is each person, and that will help us. So what we do is we know Kate. We can use, if we had Kate's age, we could multiply that by 2 to get Allie. And if we had Allie, we could add 5 to get Josh. And then if we said the sum of Kate and Allie, so if we had Kate and Allie, it would equal Josh. How old is each person? So what we do is we figure out and we set one of their ages equal to x. And that's the first thing we do in this problem. So I'm going to keep this problem right here with me so I can refer back to it, because we're going to let x equal Kate's age. And then remember, it said Allie is twice as old as Kate. So then we would say 2x is going to equal Allie's age. And if 2x equals Allie's age, then Josh is 5 years older than Allie, so 2x plus 5 equals Josh's age. These problems can seem very daunting at first, challenging. But if we take them step by step, sentence by sentence, and just break them down, we can break them into algebraic expressions. Now it says the sum of Kate and Allie's ages is the same as Josh's age. So that means if I take Kate plus Allie, so x plus 2x equals 2x plus 5. Now it's starting to look like an equation that I can solve algebraically by combining like terms and isolating my variable. So x plus 2x is 3x equals 2x plus 5. Let's move our x over here. Minus 2x will cancel out. Minus 2x. This becomes x equals, and we just have 5 left, 5. We are not done because remember this problem said how old is each person? Currently we know that Kate is 5. So let x equal Kate, that equals 5. 2 times 5 is going to be 10. And then 2 times 5 is 10, plus 5 equals 15. Now we have said Kate's age is 5, Allie's age equals 10, and Josh's age equals 15. Now we have answered the question. And this is how I can solve multi-step equations.